In this video, we're going to talk about accuracy and precision. And for accuracy, it's just how close a measured value is to the accepted value. It can't be determined just by one measurement. It depends on the quality of the measuring device. And if we look at a target as an example, accuracy would be what you're aiming for, or the bullseye, right? Precision is going to be how close a series of measurements are to one another. So precision is determined by more than one measurement, and it's going to determine on the skill of the person that's measuring. So let's take a look at a few examples and determine whether they are accurate, precise, maybe they're both, or maybe they're neither. So look at these arrows. So whoever's shooting these arrows, they're getting them all in the bullseye. So this would be very accurate and also precise because they're all in the same spot. Okay, this one only has 3 darts, but they're accurate. They're all in the bullseye, and so that means it's precise as well because they're all in the same spot. Here's another target. So we've got some off there. Oh, there's one in the bullseye. Another one. So this could be considered accurate because you got a couple in the bullseye, but it wouldn't be very precise because they're not in the same spot. So it's accurate but not precise. So here, this person, maybe they're just starting to learn how to use a bow and arrow. We're not hitting the target at all. The arrows are going every which way. So this one would be considered neither accurate nor precise. These are all pretty much in the bullseye. So this would be considered both accurate and precise. So let's take a look and see what this looks like with measurement. So remember, accuracy is how close a measured value is to the accepted value. So if we know that the density of water is 1.00 grams per milliliter, and these are the measurements that we got, 1.03, 0.98, 1.01, 1.00, and 0.99, do you think that that is accurate or precise? Or maybe it's both. I would say it's definitely very accurate, and I would probably say it's precise as well because they're very close together. Remember, precision is how close a series of measurements are to one another. So precision is based on how well you can measure. You might have a tool that's not calibrated, but you can still do a good job measuring. So remember that density of water is 1.00 grams per milliliter. And this person got 0.89, 0.87, 0.89, 0.88, and 0.88. All these measurements are far off, so they're not accurate, but they are precise because they're all close together. So let's take a look at some more. So the boiling point of water is 100 degrees Celsius. And what we got was 89 degrees Celsius, 91, 90, 91, and 80. So if you think of that 80 as an outlier is just one that doesn't match the other ones. These are precise, but they're not accurate. Let's look at the atomic mass of carbon, which is 12 atomic mass units. And we got a measurement of 11.95, 12.01, 11.97, 11.98, and 12.03. So these are accurate. They're really close to the real value, and they're also precise because they're all close together. Couple more. The electronegativity is 3.8 for fluorine. We got 2.1, 1.6, 3.5, 2.8, and 4.2. These really aren't close together, or they're really not close to the right answer, so I would say this is neither. The evaporation of temperature of isopropyl alcohol, that's just rubbing alcohol, is 83 degrees Celsius. So our answers are 91 degrees Celsius, 89 degrees Celsius, 90, 89, and 90. So they're all really close together, but they're not correct. So this would be precise, but not accurate. Are you getting the hang of it? I hope so. If you have any questions, ask me in class.